This tutorial video will show how to set up a level measurement system using the Rosemount 1151 DP transmitter. The Rosemount 1151 DP transmitter is mounted on a pole beside the lab bench and will be used to measure the level in an open tank located nearby. Before we can connect the level transmitter to the tank, it needs to be calibrated first. Let's look at what the calibration range should be. The calibration range is determined by three factors: the transmitter mounting location, the local gravity, and the density of liquid being measured. The level transmitter is to be mounted at the same elevation as the bottom tap on the tank. The local gravity is approximately 9.81169 meters per second square. And the liquid being measured is water at 4 degrees Celsius, which means the density is approximately 1000 kilogram per cubic meter. You'll notice that the water used is probably not this cold, but to simplify the range calculation, this density will be used. There will be a small error in the level reading due to this assumption, but it should be negligible. The level transmitter is to be calibrated with a low range value, or LRV, at 10 centimeter water level, which is approximately 0.49 kPa differential pressure on the level transmitter. The upper range value for the transmitter will be 90 centimeter from the bottom of the tank, resulting in a differential pressure of 8.34 kPa on the transmitter. The transmitter will be calibrated using this differential pressure range. Bench calibration hookup consists of two parts: the output wire connection and the input sensor connections. We will focus on the output wiring first. The Rosemount 1151 is a standard 2-wire transmitter, so we need a power supply source and an ammeter, in this case, the Fluke. To connect up the device, I recommend following the conventional current flow. This will help prevent reverse polarity. Begin by assuming the current is flowing out of the power supply into the level transmitter, coming out of the negative terminal of the level transmitter. The current flows into the Fluke, positive terminal, and then coming out of the Fluke, we terminate back to the negative of the power supply. This completes the transmitter output wiring. For the transmitter input side, we need to supply air to the high side and vent the low side in order to produce the desired differential pressure. For this, we'll need an air regulator and a pressure indicator in order to monitor the pressure being applied to the level transmitter. Instrument air supply is applied to the upstream side of the regulator. The regulator then regulates the output, which is connected to the high side of the level transmitter, as well as to the pressure indicator. The low side of the level transmitter is vented to atmosphere. This completes the input connection to the level transmitter. The complete bench calibration hookup should look like this. Let's go to the bench and hook up the level transmitter for calibration. We begin the calibration hookup by wiring up the level transmitter. The level transmitter has been pre-wired to the junction box shown on the left. To determine where on the terminal strip the transmitter is wired to, identify the tag on the transmitter and match that up with the terminal strip tag. The 24-volt power supply is mounted on the control panel and cannot be connected directly to the field junction box. A wiring path between the field junction box and the control panel has been provided. JB1B on the field junction box is connected to TS1 on the control panel. This layout is to simulate the hazardous side or process area versus the safe or control room area. To connect the transmitter to the power supply, we need to bring the transmitter from the field to the control room side. To do this, connect LT1C to one of the conductor pair on JB1B. The level transmitter is now connected to TS1 on cable pair 3. We can now proceed to wire the 24-volt power supply and the fluke to the loop. Start by connecting to the positive on the power supply. The current will flow from the power supply positive out to the transmitter positive, which is the red on the cable pair 3. Coming out of the transmitter on black, it will flow into the milliamp port on the fluke. Coming out of the common port on the fluke, it will complete the loop at the negative of the power supply. The completed loop should look something like this. You can go ahead and power on the transmitter. Turn on the fluke. And set the fluke to measure milliamp. If you wire up the transmitter properly, you should see about 4 milliamp showing on the fluke. We will now connect up the input side of the level transmitter. Recall that the output of the regulator is sent to the level transmitter and the pressure indicator. We will be using the 0 to 4000 mm H2O regulator, which has 2 output ports available. First, power on the crystal gauge by holding down the power button. Then change the units to kPa. Then zero the gauge by holding down the 0 button until you see our dashed line. Before connecting to the crystal gauge, remove pressure at the ports by backing out the regulator. Be careful not to spin the knob too far, as it may come off. As good safety practice, connect to the gauge first, then to the regulator. The next step is to clean and dry the DP cell. Begin by opening both bleed valves on top of the transmitter. This will allow any trapped water to drain out of the transmitter. Next, connect the tubing to the high side of the transmitter. You only need to hand tighten the fittings for now. Once the tubing is connected to the second regulator output, then apply the air until you begin to hear a hissing sound. Let the air dry the high side of the DP cell for a few seconds. Then remove the air and close the bleed valve. Repeat these steps for the low side of the DP cell. The last step before calibration is to confirm that the range jumper is in the proper location. The range jumper should be in the middle for the range that we're calibrating the transmitter. We are now ready to calibrate the transmitter. Move the air hose to the high side of the DP transmitter. Ensure that it is tight this time. Adjust the regulator for 0.49 kPa pressure. Then adjust the 0 screw on the transmitter for 4 milliamp output. When done, adjust the regulator for 8.34 kPa pressure. This is the upper range value for the DP transmitter. Then adjust the span screw on the DP transmitter for 20 milliamp output. Repeat the zero and span procedure until both ends are accurate. You don't have to be perfect here. Come as close as you can to the required output. When you are done calibrating the transmitter, back off the regulator until about 0 kPa and disconnect the hoses starting at the regulator end. The next step is to connect a level transmitter to the open tank. But first, we need to make sure that the transmitter is at the same elevation as the bottom tap. It's about 87.7 centimeter here. And the transmitter is about 895.3 centimeter. We need to lower the transmitter to about 87.7. That's about good there. When connecting to the open tank, ensure you are using the 3/8 white tubing and use 2 wrench when tightening the fitting on the bottom tap valve. Connect the other end of the tubing to the high side of the DP transmitter. To allow flow into the tank, we need to open up the Fisher valve located on the left. To do this, we will manually open the valve by sending air to it. We will be using the bottom regulator, so connect one output to the pressure gauge and the other output to the valve. Ensure the last connection is to the regulator. Fully open the valve by sending 100 kPa to it. Last thing before we allow water to flow into the tank is to close all the block valves and ensure that the 3-way valve is pointing to the tank we're measuring. Then open up the solenoid by turning the hands-off auto switch to hand. Allow water to rise halfway up the tank, then switch the solenoid off. Next is to flush the sensing line of air. Begin by opening up the bottom tap valve. Get some paper towel or rag ready to catch the water. And open up the bleed valve on the high side. When you see water coming out, close the bleed valve and tighten it. Check to see if there's any bubble in the sensing line. If you see any bubble in the sensing line, you have to drain the line and start all over. Verify the level reading by lowering the water level to 10 centimeter. At this point, the transmitter should be reading 4 mA. If the transmitter is not outputting 4 mA, it could be due to the error in our calibration and the assumptions made earlier. To correct for this error, zero the transmitter at this point. Raise the water level to 90 cm to check the transmitter level reading at the top end. The transmitter should be outputting approximately 20 mA at 90 cm. If your level transmitter is measuring accurately at 10 cm and 90 cm, you have successfully commissioned the level measurement system. All you need to do now is verify the level reading at different points in your range.